series. I have a 3-year-old son named Michael and a 6-year-old son named David. Our lecturers tonight are Michael O'Sullivan and David Martin, who looked at me kind of strange when I said when they left the students there they should be sure to have their coats on and put their mittens on and zip up their coats. I'm so used to saying that when I talk to David and Michael. I hope they could excuse me. David Martin is a classmate of mine and Tony Costello's. We were at Columbia together the year before the big Columbia riots. We left at a good time. Somebody said to them when they saw them this afternoon that they were the first lecturers to get here in a long time that got here the day of the lecture on time with no difficulty, and they pointed out to them that it actually took them a year to get here. They were supposed to be here last year at this time. So it's about time they got here. I'm going to introduce David, who I've known for a number of years, and David is going to introduce Michael. David Martin has a Bachelor of Architecture from the University of Southern California and a Master's from Columbia. And after Columbia, he was awarded a William Kinney Fellows Traveling Fellowship, which he used to travel around the world. He's received a number of awards in architecture for residence in Los Angeles, from the AIP, an honor award. He's a registered architect in California and is president now of the Southern California chapter of the American Institute of Architects. He serves on the board of directors of Los Angeles Beautiful and the Contemporary Art Council and the Los Angeles County Museum. And he is currently partner and director of design for Albert C. Martin and Associates, Planning, Architecture, and Engineering in Los Angeles. And now I've learned that they are branching out across the country. In his capacity as director of design, he has worked on a number of projects, including corporate headquarters, schools, office buildings, a variety of building types that I think he's going to describe to you. One of the things that doesn't appear on his biodata is that the very same David Martin, who's the architect, is also the winner of the. He builds and races his own cars, and he's a recent winner of the Baja 1000 race on the Baja Peninsula, and he's been asked by a lot of automobile products manufacturers to have his name in their ads and pictures of his car and stuff like that. It doesn't appear here on this resume, but I think he's really proud of that, and so I wanted to mention that. We're really delighted to have David Martin and Michael O'Sullivan with us here this evening, and I'm going to turn the microphone over to David, and after a little introduction, he's going to tell you about Michael. Once again, it's very nice to have them here with us a year late.
Thank you very much, Marvin. I would like to also introduce Michael O'Sullivan. Michael O'Sullivan is an associate of mine, and among other things, he is the State of California chairman, or was in '76, the chairman for the State of California AIA Energy Conservation Committee. Last year, he was an advisory member to the State Energy Commission. He's one of the most talented designers in the country, and I don't know what else to say. Michael and I happen to love architecture. We have a lot of fun at it. We work hard, play hard, and we're really happy to be here. It's kind of interesting, born and raised in LA, to get out the Chicago airport, and standing out in the cold is really not that bad. LA is kind of this sameness all the time, which is also very, very interesting, but to get into another climate and another environment is really kind of a lot of fun. But I think a way to start this evening is to really tell you who we are, what we're about, and what the firm is about. And I'll start out with a little bit of history. My grandfather came out to LA from Chicago a while back, and he went to work for one of the most prominent architects in town. And this architect happened to be married to the daughter of a very famous department store owner. And my grandfather was working on the working drawings for a new department store. And halfway through the working drawings, it ended up that this architect was having an affair with his mistress, and the whole family found out about it. And they immediately fired him from the job of designing the department store, and they hired my grandfather. And out of this scandal, that's how our firm started in 1906. And I just think that's a great beginning. We've been working real hard at it for the last 76 years, and a lot of things are very important to us. If we put on the slides, we'll show you some of the early work. I think we have a lot of ideas about architecture that we would like to communicate to you. But first, let me show you some of the work that we've gone through. These are our great focus slides. I have no comments on these. The firm did the Los Angeles City Hall, which maybe some of you have seen in the city, and a few other California state monuments. But here's some of the more interesting things. This is the Los Angeles Swimming Club that we designed. But unfortunately, the slide cuts off the Model T Fords that go along the side here. And this is a beautiful archway from the $1 Million Theater on Broadway in Los Angeles, which I guess before Hollywood and before the Ambassador bungalows and so on, the $1 Million Theater was the premier motion picture house where Charlie Chaplin and some of the great movie stars were kind of hung out in downtown Los Angeles. I'd like to point out some of the interesting things about that archway. They didn't line it all up. Everything is off just a little bit, and I've always admired how that goes together very well. Had it been lined up, I don't think it would have been as successful. There's the department store, the Hamburger, which is now the May Company. Some of you may have seen pictures of this kind of flashy Art Deco May Company at the corner of Wilshire and Fairfax. That was one of our buildings and is really representative of the Art Deco style in Los Angeles. Pan Pacific Auditorium and a few others are also a great style that was going on. This is 1936. Our firm has been responsible for many of the buildings in the urban buildings in downtown Los Angeles, and I suppose we're a fairly large firm for Los Angeles, but we're not a national firm. Michael and I represent a generation of people who are trying to see the firm gain more attention and become more national so we can have more opportunities in our work. But these are, in Los Angeles, the downtown areas are actually filled with a lot of parks and a lot of open space compared to a lot of other cities. We're developing a second-level pedestrian way like Minneapolis, but it is an unusual situation where each building does have a series of large parks with a lot of great things happening, kind of woven through the city. This plaza here is a conscientious effort in the landscaping materials to recall some of the vocabulary of the early California, the Spanish pots and the tiles and so on, but it's a space that really works very well in the city. Arco Towers in the background is one of our projects. I'll give you an idea of the scale of some of the things that we've worked on. Security Pacific and Arco Plaza, we did the Water and Power building here. Arco Tower, the first impression is that it's a very nice, well-detailed Miesian type of a building. But the more, I guess it's been up for about 10 or 15 years, the more that we live with it, the more some subtle things occur that I'm very proud of. In Los Angeles, one of the big problems that we have with high-rise buildings, of course, is the earthquake problems. And since the computer has come on board, we've gotten quite sophisticated with the seismic analysis for tall buildings. We can take a deck of cards that represents any major recorded earthquake that's ever hit California, and we can mathematically model our buildings to a disaster earthquake just to see how they'll perform. And for example, on one of these towers, we have a movie of this where we have a cross-section of the tower, and then we can apply the equivalent of the El Centro earthquake or the Long Beach earthquake or the San Fernando Valley earthquake, and sit there and watch how that building sways in the breeze. And we can mathematically pick out where the weak links are and so on. And it's interesting that buildings like this are much safer than some of our 10-story shear wall buildings that are designed stiff. These buildings just sway. The best expression of the structure for a building like this is a Varandale truss on the outside of the building with the core in the middle that just holds the vertical supports. With this technology, our firm has gotten into some other interesting kinds of projects. This is just a part of a tower that's about 1/3 of a mile high, where with our technology we have analyzed, it's a three-dimensional space frame, the entire tower to measure its performance in wind and earthquakes and so on. We also do a lot of industrial work and graphics and this kind of a work. I'll go through a few of the slides. Spec office building, I'll point out one thing that's kind of interesting. This is in Century City. Here we were running the mechanical systems in conjunction with the columns up the outside face of the building to service the building. So we had the structure and the mechanical systems working simultaneously. This is the Sears West Coast headquarters. It was probably one of the first mirrored glass buildings on the West Coast. Thought it would be very appropriate many years ago to make it in the form of a cube. They call it the Flash Cube building, which I think is great. It doesn't rotate though. It's a steel case furniture manufacturing plant. Behind this little jewel box is a very large factory that makes all the steel case furniture. We've accented the entryways and so on with the very bright enameled entrance. They use their own furniture in their offices. Another building along the same vein, this is actually a remodel of a Hoffman Electronics building where we've done a very simple building and accented the entrance in enameled panels. I guess this is probably about 4 or 5 years ago. Graphics is important. The brick building was there. It's all remodeled. This is a little building that I did down in Newport Beach, an office building where we wanted balconies and the office tenants to be able to walk outside. And actually it wasn't planned for, but the owner moved into the top floor in an apartment up there, and he lives there, and there's a couple of stores on the ground floor. This is a very handsome building that Michael O'Sullivan designed for Parker Hannafin down in Newport Beach. The whole site was done on a 60-foot module, and these manufacturing buildings, you can unclip the walls and expand anywhere on the site in a 60-foot by 60-foot increment. The bridge there is actually the entrance and the lobby to the building with the office facilities on each side. This is a detail shot showing some of those panels, but I think one thing that I think is very interesting and very successful is the use of a little bit of accent color to really set the whole thing off. It's a project down in Houston, Texas that is now under construction right now. It's a test and demonstration laboratory for an oil-related company. The lake in front is actually a reservoir to hold the fire water for the sprinkler system in the building. And the office building connects two manufacturing facilities, so from the office space you can look out onto the manufacturing and the testing facilities. This is the building for James B. Lansing, $18 a square foot. It's a very large factory with a very inexpensive budget. The building, as you can see from the plan, can never be perceived from any one place, and because of existing buildings that it kind of wraps around, and so it's kind of a continuous terraced wall, and that's the only way you'll ever really see it. We used a modular red block on the front people part of the building, and then as we moved to the back, because of budget reasons, we took the same module and went to a concrete block. So the back of the building where all of the trucks and the machines are is a gray concrete block. The front is a red block. And we've done this kind of super graphics number where the two colors of block meet on the two side elevations. It's nearing completion. I think you got an understanding that we were going to talk a bit about building skins and energy conservation. And I'd like to give you some observations that we have about the skins of buildings and some of the experiences we've had. This building here was done for General Telephone, was done about 1950. And in the 50s, in Southern California at least, there wasn't too much commercial building going on or too much architecture going on after the war. So in the 50s, air conditioning was still kind of a new thing. And people didn't trust it very well, not in Southern California at least. And so we made the windows small, and we put overhangs on the buildings, just in case the air conditioning broke down. And it's kind of an interesting idea that's coming back. But as we moved along, this building here was done a few years later, maybe even into the 60s, where we took that overhang and we glazed it in with a translucent panel. That translucent panel would then block the rays of the sun and yet give a very comfortable space, office space on the inside. And again, we never thought of leaving that sunscreen off because we weren't sure the air conditioning would really be on all the time, really make it. Here's a further evolution. We took the translucent panel and we used gray light 14. It looks very dark here, but when you're inside that office space, this was probably 65, you look through two layers of glass, and as the sun came in, the sun kept getting more and more tempered, so that you again created a very comfortable space. You felt enclosed sitting in that space because you saw something out beyond you. And then here's a building where the frame came out and there's layers of glass that you can see in there, the two layers of glass. Again, it's an evolution of a sunscreen. And finally, the way I observe it, this is not one of our buildings here, but the glass block became very, very common in the 60s. Very common because the air conditioning the systems were so good, energy was so cheap, and why not? All you had to do is put the diffuser on the glass line, and it was an acceptable solution. Close the drapes once in a while. The next evolution is a very interesting one. They came up with mirrored glass. And mirrored glass started to be used before the energy crisis hit us. And the mirrored glass did a very wonderful thing. This is the Sears Tower again. This is mirrored glass used in thermopane. Two coatings of silver mirror on the inside of the thermopane. It works so well technically that it's as good as not having windows at all. It was just a tremendous energy breakthrough that it only took a couple of years in this building to pay for the additional cost of the glass because you didn't have to put in as much air conditioning. And now this was, I guess Sears was done about 8 years ago. And now there are 127 kinds of mirrored glass. Technically, it's one of the only materials we'll even consider in Southern California, at least. And you can get it in every shade, every color. I don't know if this means that mirrored glass boxes are here to stay or not. One of the things that I'd like to pose is we really don't know where we're going in terms of the crisis of energy that has hit us. Let's see. Let me talk a little bit more about the skins of buildings. I just got back from a fabulous trip in South America. In South America, you cannot buy air conditioning systems. Or if you can, it's just not like here. You can buy the little package units that you fit in the window, and you see great office buildings with little dots of package units all over the facades. But because they couldn't live with glass boxes in their office towers, they developed a fabulous system of grills and louvers and fins to protect their buildings. And it's a system that has just totally amazed me. And they've developed an economics to be able to do this. And a lot of you have seen this in Europe. In South America, it seems to me they've gone beyond some of the things that I've seen in Europe. Shades that go up and down, that open and close, that are all beyond the glass line. Things that flip up. There's the shade that goes up and down and the box that holds it below all over the glass. Quite an incredible solution to a problem. One thing that we've found through computer studies and so on is mirrored glass makes all of this not very cost effective. Mirrored glass performs better, but this is just a fabulous articulation of the skin. Let me show you some of the buildings. I want to say a few things about our process of design and what our process of design is recently. In California, and I think everywhere, and I know all of you, the students are very much aware of it, the crunch of the energy crisis is not only very real, but it's kind of a dominant thought in our design process. But first of all, let me go through a few studies of the things that we're doing recently. We're looking at large buildings and solar panels and all kinds of interesting vocabularies. This is another building that Mike's worked on, Mike's designed. It's a building that for Prudential, their Western headquarters. It goes in a city called 1,000 Oaks. And they have a 3-story height limit, and you can't cut down any of the remaining oak trees that they have. We don't have all of the slides of this, but this is a building that matches our new California Title 24, which is a very strict energy budget related bit of legislation. This building is essentially an open plan. It has an atrium running all the way down its entire length with Northlight monitors and stainless steel on the inside of the Northlight monitors that bring light into the atrium. It has very large overhangs. The mirrored glass, it's protected. It is of a material that is required by the community that it goes in, so it'll totally blend into the hillside there. Here's where I'd like to stop and talk a little bit about some of our thoughts on architecture. I have a lot of maybe unrelated thoughts, but let me go ahead here. The other day, I was with my father-in-law, and we were listening to some music. And I think we were listening to, you've picked A Fine Time to Leave Me, Lucille. I don't know if any of you have ever heard that. Just before that, yeah, great, isn't it? Just before that, we were listening to Gato Barberi, and before that, Disco Star Wars. And my father-in-law said, you know, in 1940, there was only one kind of music, and it was great. And this was, of course, was the big band swing. And it was really kind of an interesting thing. And a lot of things, there's another thing. In 1900, 1903, the entire modern movement in painting occurred. I think there were 5 or 6 people. They all knew each other. They all had dinner once a week in a cafe in Paris. And they were the entire, that was all there was. There was one way, you know, Picasso and Braque, and they were all buddies, and one singular approach to a problem. Each one had their individual ideas, but that was the beginning of the modern movement. When my father went to college in 1936, there were 2 ways. You were either Beaux-Arts or you were modern, and there was always a big argument of which. And I don't know how you do it in your school in this day and age, but there's got to be at least 10 validated approaches to how you solve problems in architecture. That because of the media explosion and because of the communications that we have, that there are so many ways to approach problems. There is so much talent. 30,000 students graduating from schools of architecture every year. Somebody said there's more architecture students now than there are architects. Tremendous talent, a tremendous multiplication of ideology. It's happening in all of the arts, in music, in fine arts, and so on. There's not one way to do anything anymore. And what occurs to me in trying to go from, in this architectural form, from here into something that is beyond here, and trying to understand how do we approach the design of buildings in an energy crisis, and what is the right way to design a building now when it's not going to be built for 5 years. I'd like to identify a couple of approaches. This is a steam plant that's right down the beach from me, and that's a technological approach. And then we're all very familiar and very delighted with the Beaubourg Museum, which is really deals with the technological imagery. And there are entirely 2 ways, different ways of solving a problem. In the steam plant, a bunch of guys sat down to solve a problem, and they came up with a solution that did something. And in the Beaubourg, in a very valid approach, they sat down and said, we want this building to have this kind of vitality. And after they decided that, then they went in and solved all the problems. Both are very valid approaches. It's done all the time in architecture. Philip Johnson's Pennzoil Plaza, he decided what the image should be, and then he solved the problems. But it seems to me that the choice that I would really like to pursue, and it's one of 10 or 20, is that I'd like to find out what the technological solutions to our problems are, and then have the solutions stem from that. I think Marvin overemphasized that I am interested in building race cars. And it's a funny thing about race cars. It's like architecture, I think. You work out a design, a detail, a mechanical system. And, you know, you have to admit you want it to look good. But if you start out with a thing, wanting a connection of a trailing arm to some suspension member, if you want it to look good and clean, probably it'll break on you. But if you want it to work, and you want it to hold up in the race, it'll look beautiful. And it's a matter of solving the problem, and then it'll look good if you solve the problem correctly and if you do it well. Fascinating steam plant. I think some of the details are a little better than the Beaubourg, but we have a focus problem. Right. Excuse Excuse me. I'm sorry. I wanted to make a comment. Leger is my favorite artist. He took the imagery of the machine and the machine age and dealt totally with that imagery. And the circles, the squares, the triangles, the whole geometry was really an exciting, expressive kind of a geometry. I think that's a very valid thing to do in architecture, but I think it's different than what we're trying to do. I wish that I could show you a series of slides that solve all the problems and are all the right answers, but I can't do that. I'm mixed up here again. Simply expressing the mechanical systems, exposing them and painting them bright colors this is something I did in that little office building, but it's not the right answer. It doesn't solve the technological problems. I think you have to go way beyond that. When you do this kind of a thing, the machines make noise, the ducts rattle, tremendous problems are created, and you're not really solving the problem by simply doing that. It looks neat, it's fun, and it's kind of a happy thing, but I think our real problems we have to go beyond that. Our friends at JBL, I think, do a very handsome thing. You can rip the screen off, and then the true beauty of the speaker shows the true function. They're not interested in expressing the wire and the acoustics and the construction of the box. They cover that all up, but they do show you a very good indication of how the building works. This is a very, very simple building with a very, very simple program. We oriented this building so that the mechanical towers and the stairs were on the east and west elevation. We faced the long elevation, the south side. We planted a heavy row of trees on the south side and just left the north side alone. The building has one entrance. That's in the corner, and you can see where that entrance is. And this is, I'm happy with this building as a first approach to really understanding what the structural system needs to be, what the mechanical system needs to be, how do you reflect that in the program, how do you orient the building correctly, how do you use the right amount of light, the right amount of glass, cut down on the electrical light, and create a very simple, efficient building that matches the program. This is another project that we're working on right now, right at the moment. We've trended away from the very bright colors, but it's a shopping center. It's a little bit hard to understand here. We picked, it's about 1 million square feet. We picked one module. This building has offices, shopping centers, parking structures, a whole series of things. And we tied the whole thing together with a structural module that we don't have to change and transfer and make complicated. And this becomes the whole basis of the architecture. We took these slides Thursday. We're working on a building in downtown Los Angeles. And if you look at this, and get the laser beam, there we go. The site's here. These are the Arco Towers right here, Portman Hotel, a 60-story building here and a 40-story building here. And we knew we took a couple of assumptions. We knew we needed a building programmatically that was about 40 stories tall. We knew we wanted a square floor plan building. And we knew that we wanted a certain orientation. Now, what are the statements that this building can make as far as energy conservation? We started looking into a lot of ways to bounce off the sunlight onto at least the first 10 feet of office space. Gunnar Burkhardt was dealing with this about 2 years ago. We know that we can gain so much by cutting out electric light as far as energy conservation that this is a very legitimate approach. We don't know what the final solution is as far as the impact of this kind of a thing on the building and on the aesthetics, but that's where we're starting. Now there's one problem with doing this, that this building is in the shadow of these buildings quite often, and this is a mirrored reflective glass building. So these are the kinds of problems that we're looking at, and what is the effect of the shadow when you do this kind of a thing, or the effect of the mirrored glass building in the neighborhood, and how does this affect the building on a yearly cycle? Again, various ways to deal with the problem of lighting up the inside so we don't have to use electric light. This is by the way, we've already developed a rule of thumb that 33% of the window wall we use mirrored glass. The rest of it is a very highly insulated wall, but that will give us a very good rating as far as the exterior skin. Now we're trying to figure out how to get more light, usable light, into the workspace. Here the sunlight comes down. This is a device that would bounce it back off the ceiling and back onto the workspace. Okay, we're missing one of the slides. Just simply by using, in this area of the window wall here, highly chrome-plated Venetian blinds, and focusing those blinds in the building so that they pick up the sun and bounce them back into the building would be one very simple way to solve the problem. I think that there should be more effective and more permanent ways, but just that one device would have a payoff for us. I'm kind of wrapping up my side here. This is a little moonlighting job that Mike has a few of these. I have a few of these. It's not all just big projects, but this is a project that I did a couple of years ago. This is Mandeville Canyon. This is one that Mike worked on.